Hi guys, and welcome to another exciting episode of Worms Maths Academy exams. Um, okay, I had a few people ask me for 2017 Northern Hemisphere exam 2. So I'm going to run through that now. Obviously all the normal stuff. Multiple choice. First one, the gradient of a line perpendicular to the line that passes through that. Okay, so the gradient of that line is negative 6 minus 0 on 0 minus 3, which is negative 6 on negative 3, which is 2. So m perpendicular is going to be negative a half. Obviously, they try to trick you by giving you 2 as well. This has a period. It's 2 pi on n. N is a quarter. So 2 pi on 1/4, which is 8 pi. Nice start. Simultaneous linear equations have a unique solution. So we want them to have a different gradient. So I'm going to rearrange this one. Y is negative mx on 7 plus 12. Rearrange this one. Y is equal to negative 7x on m plus 1. Okay, so we've got our gradient. Negative m on 7 is equal to negative 7 on m. Cross multiply. M squared is equal to, well, cross out there, they're both positive. M squared is equal to 49. M is plus or minus 7. So if m is plus or minus 7, they've got the same gradient. But if I want a unique solution, it's all values except for when m is negative 7 or 7. If it's negative 7 or 7, we either have infinite solutions or no solutions. Okay, this graph reflected in the x-axis, negative f of x, so it's going to be negative 4x to the 1/3. Translated 5 units to the right and 6 units down. X minus 5 will bring it to the right and 6 down, so subtract 6. X minus 5 to the 1/3 minus 6. Negative 4. Okay, so it's either going to be that or that. Oh, because it's to the right, so it's going to be D. That's got a plus at the end. That's got a plus in here. That's got a plus in here. This one's only moved down one, up one, sorry. Which of the following is the inverse of that function? So remember, it's multi-choice, so we don't really care about working. X equals 2 on root 3 minus y plus 1. X minus 1 is equal to 2 on root 3 minus y. Switch those two. So we get root 3 minus y is equal to 2 on x minus 1. Square that side. Subtract 3. Divide by negative 1. Negative positive. So it's going to be y is negative 4 on x minus 1 squared plus 3. Okay, so it's not that. Okay, so we've got a few answers to choose from. This is between negative infinity and 3. So I can just quickly sketch it to work out what the range is. Negative infinity to 3, 2 on root 3. Excuse me. 2 on, I don't remember what it was. Root 3 minus x. And then, stupid thing. And then plus 1. Or was it minus 1? It would be minus just because I wrote plus. No, that's right. Okay. So negative infinity to 3. Now 3 looks like it's an asymptote. So my range Looks like it's from 1 to infinity. So that's going to be my domain in this case. 1 to infinity, and it can't include 1 because 1 is an asymptote. Okay, here you can use your CAS. You can use prop frac on your CAS, so 3x minus 5 on 2 minus x. 3x minus 5 on 2 minus x. Highlight, transformation, fraction, prop frac. So negative 1 on x minus 2 minus 3. Negative 1 on x minus 2 minus 3. So x equals 2, y equals negative 3, gives us 6b. Okay, they will not intersect or touch, so we'll let them be equal. Equals kx minus 2, x squared plus 3 minus kx when I bring that across, plus 2 is equal to 0. So my discriminant is 3 minus k squared minus 4 times a, which is 1, times c, which is 2. And that has to be not intersect or touch, so it's got to be no solutions. So 3 minus x squared was it minus 8? Minus 8 is less than 0. So negative 2 root 2 plus 3. That won't be equal to, so it's got to be a. Okay, part of the graph of the function, which one is the average value of the function over the interval negative 8a? So there's negative a to a. If I went from here to here, that and that would cancel each other out, so my average value would just be 0. If I go from here to here, I'd take those blocks and put them over here, which means that my average is going to be that value, which is a on 2, because y equals a. So it's going to be a on 2. The range of this function, negative a half to 0, 0 to 2, log ax squared. Okay, let's clear. Natural log of x squared. Zoom initialize. Okay, we had negative a half to 0. So negative 1 half is less than x, which is less than 0. So that's negative infinity to whatever that value is. And then the other one was from 0 to 2. Can't be equal to 0. Okay, so that's got a higher range, and the maximum is going to be when I sub 2 into that function. So I'm going to get log e of 4. So you go negative infinity to log e of 4 with a square bracket. No, negative infinity, negative infinity. It's got to be this one. Log e of 2 squared. Bring that down to the front. Gives us 2 log e2. The tangent of the graph of that is parallel to line with equation 3 at the points where x is equal to the tangent, the derivative, dy dx, is derive sine, and you get cos. So 3 on 2 cos 2x is parallel to the line, so that equals 3. So we get cos 2x is equal to I stuffed that up. I integrated. Oh, well, I didn't. If you bring your 2 out the front, it's going to be 6 cos 2x, and that equals 3. Cos 2x is equal to 1 half. So if cos 2x equals a half, special triangle 1, 2, root 3, my angle's got to be pi on 3. So I would get 2x is equal to plus or minus pi on 3 plus 2k pi. K is an element of z, or n is an element of z. X is, let's put that over 3. That becomes 6. Actually don't. Because when I divide 2 across, that'll be plus or minus pi on 6, and then plus k pi, which is that one, n pi plus or minus pi on 6. The bag contains 5 blue and 4 red marbles. A sample of 4 marbles is taken from the bag without replacement. The probability that the proportion of blue marbles is greater than a half. So if it's greater than a half, I've taken 2. So if it's greater than a half, then it will be 3 out of 4 or 4 out of 4. So I'm going to use combinations. I've got how many blue balls? So I want 5 choose 3 times my red balls, 4 choose 1 because I've got 4 altogether, 9 choose 4 on the bottom, plus 5 choose 4 blue balls, 4 choose none, red, 9C4. Okay, so I'm going to put in a divisor, and then, oops, one too many, NCR. Okay, so I had 5, 3, 4, 1, 9, 4, and then the same thing, but this time I had 4 and 0, and then I want to add those together. 5 on 14. Okay, the maximum temperature reached by water heater in a kettle is normally distributed with a mean of 95 and a standard deviation of 2. When the kettle is used, the proportion of times reached for the kettle is greater than 98. Okay, normally, so interactive distribution, continuous norm CDF, 98, infinity, 2, 95.0668. That seems pretty straightforward, almost scarily. Okay, the probability distribution for a discrete random variable is given by that, the mean and variance. Okay, so E of x is our mean, which is that multiplied, negative a, that multiplied 0, plus 2a plus 2b, which is going to give us a plus 2b. We need E of x squared for the variance, so I've got to square that. So I get a plus 2a plus 4b, which is 3a plus 4b. And we know our variance of x is E of x squared plus 4b minus E of x all squared, a plus 2b squared. 3 plus 4. It's probably quicker just to do it by hand instead of typing it out. That's plus 4b minus a squared plus 4ab plus 4b squared, which is going to give us 3a plus 4b minus a squared. Okay, it's going to be that one, because it can't be that one, because we've got too much stuff left over. And it's just E of x, the mean is a plus 2b. Okay, the rule of the function of this graph, so it could be sine or cos. I'm going to go with cos, because that looks like a cos graph, and it starts at negative cos. My middle is at A. We go down A and up A. So my center is A. My amp is A, but it's negative. So we would have y equals negative A cos and then plus a. My period's 2a, so 2 pi on n has to equal 2a. So n has to equal pi on a. So pi x on a, which is that graph there. Negative cos. Okay, y equals e to the kx touches a graph of its inverse at exactly 1 point as shown below. Okay, e to the kx and its inverse. So I can sketch e to the power of k times x. Whoa. Let's change our values of k. Let's go negative 10. 10. Step is 1. Okay, but let's do it, say, given, what are the values? E and e squared. So, given k is equal to e first. So sketch it and then sketch its inverse. Nope. E squared. Nope. I'm going to zoom in. Zoom in. Okay, the other one was 1 on e squared. And then sketch inverse. No good. 1 on e. That looks like it could be it. Sketch inverse. They touch at 1 point. So k is 1 on e. Of course, it's the last one. Okay, the area under the curve of f of x between 1 and 4, where that's greater than, is 8 units. So 1 to 4, f of x dx is equal to 8, and f of x is greater than a half. The area under 2, f of x minus 1. So 1 to 4, 2, f of x minus 1 dx. That's 2, 1 to 4, f of x dx. Minus 1 to 4, 1 dx. That we know is 8, so that's 16. 2 times 8. Minus, if I integrate that, I get x. So I get 4 minus 1, which is 3. 16 minus 3 is 13. Okay, the function satisfies that relation. F of x squared. Okay, what was my first function? Root x plus 2. So I'm going to define that first, x plus 2. And then I'm going to use the judge function in the calculator. Judge. That was f of x squared is equal to f of x plus, I don't remember if this is it, but let's give it a bash. Was that right? F of x plus f of x plus 2. Okay, the next one's x plus 2. Enter to define and check. Log 10 of x minus 1. True. So that's our answer. Okay, let f of x equal x to the m e to the ax. A and m are not 0. If x plus 2 is a factor of f dash x, then which of the following must be true? Let's find f dash x first. So integrate x to the m. We get m x to the m minus 1. E to the ax, product rule, plus the derivative of e to a to the x is a e to the ax times x to the m. Okay, what can we take out as a common factor? We can take out e to the ax, and I can take out x to the m minus 1. If I take out x to the m minus 1, that disappears, so I'm left with m. If I take out x to the m minus 1, I've got to leave an x behind, so that balances out to just give me x to the m. I don't want to change anything. So I've got plus a x. Okay, and it's saying that that's a factor of f dash of x, so it must be this factor here. So if I solve that, m plus ax is equal to 0. X is equal to negative m on a. And if I solve the other one, x plus 2 is equal to 0. X must equal negative 2. So negative 2 equals negative m on a. Cancel them. I get m is equal to 2a, which is d. Because if I've got a linear factor of that, it's also got to be a linear factor of my derivative, and that's not going to give me a linear factor, but this is. Okay, the first digit of each house number in a large address database is a random variable d. The possible values are 1 to 9. The probability of d equals little d, log 10, 1 plus 1 on d. The probability that d is greater than 8, given that it's greater than 7. The probability that, okay, greater than 8, so d is greater than or equal to 9, on the probability that d is greater than or equal to 8. So that's the probability that d equals 9, or the probability of d equals 8, plus the probability that d equals 9. Okay, d equals 9 is log 10 of 1 plus 1 on 9, which is 10 on 9, over log 10, 1 plus 1 on 8, 9 on 8, plus log 10 of 10 on 9. Okay, we can separate this apart to be log 10 of 10 minus log 10 of 9, and that'll be 1. So I get on top 1 minus log 10 of 9. Now we know that's going to be the same, 1 minus log 10 of 9. Here, I'm going to get log 10 of 9 minus log 10 of 8. Log 10 of 9 minus log 10 of 9 are going to cancel. So get 1 minus log 10 of 9 over 1 minus log 10 of 8, which is b. Okay, consider the function 2 to infinity of f of x. Okay, let's put this into the cas. X to the power of 4 plus 2 a minus 4. Is it x cubed? Let's try. Minus 4 times, let's hope that's right, x squared minus 8ax minus 8a times x plus 1. Okay, so x has got to be greater than 2. It's greater than or equal to 2. Given. I'll do that. Okay. We only want it for x is greater than 2. I don't know. Okay. The maximum set of values for which the inverse function exists. Okay, and it's greater than 2, so we've got to use the right-hand side of the graph. And it's got to go from 2 to infinity, and it can't, because it's an inverse, it's got to be 1 to 1. So I guess our main points are negative 9, 1, negative 8. So if we put in negative 9, let's go from 2 to 10. Zoom auto. Okay, so that's from 2. Let's see where the minimum occurs. G-solve. Min. Okay, so there's a minimum that occurs after 2, which means that it must go, it's got to go down and then up. So just say there's 2, 2.16 or whatever it was. That can't be 1 to 1. So now let's try -8. G-solve min. Not found. Let's see where it is. Analysis, G-solve min. Okay, so that must not be, let's see if it's a point of inflection. That is a point of inflection, so that must mean that's the point where our graph becomes 1 to 1, because it's a point of inflection. So, probably should rub them out and say from -8 to infinity. So as long as A is -8 or above, -8, you can see as we move across, that's always 1 to 1. So that's our solution. So 20 multiple choice. Hopefully we did it in half an hour or less. I'm not too sure because I wasn't keeping any track of it. But yeah, there's exam 2 multiple choice 2017.